I want to introduce you to another concurrency pattern that will further benefit applications. So here's a diagram of a common concurrency pattern, and one that I use in the demo app that I have. And that is, we have a main queue and a UI thread. It performs exclusively all UI operations like tapping and scrolling and laying out the UI, etc. We have a database queue, which is a serial queue. It has one thread allocated to it. It does one thing at a time, and it performs database operations: inserts, updates, deletes, and query. And then we have a system concurrent background queue that has n number of threads that are performing concurrently work pulled from this queue. So this works great, but keep in mind that, let's say for the database queue, we may want to do something once the database operation completes. Or for the system concurrent background queue, we may want to do something after we retrieve data from a remote endpoint. So what happens is, in this model, that work is also done on the thread and just delays this thread from being able to service other work that's sitting in the queue. So if we, for example, want to query data, and then when we get a result set back from the database, we want to loop through some rows and do something, that's still delaying pulling this work from the queue, because all this is happening on this serial queue. And the same here. If we retrieve an image and we need to decode it and then cache it in a URL cache, that's occurring on this thread, and it's blocking any additional work being pulled from this queue. Let's make a slight change to that concurrency model. So this applies to everything but the main queue and the UI thread. So here I have my database queue, but I'm going to rename it. I'm going to call it the execution queue. And this is going to work just like the old database queue. It's going to do work, except that I'm introducing a new serial queue, which is called the database result queue. In every respect, it's just like the database execution queue, except I'm going to use it to handle results or responses. So this model, actually, for each concurrency implementation, I'm going to use two queues, one for execution and one for response or result. So here I have piece of work number 3 running. As soon as I retrieve the rows from the database in a query operation, I'm done executing, and I want to throw that work into the result queue so that the work of iterating through the rows and handling and doing whatever I want to do processing wise against that result set will be thrown to another queue. This allows me to immediately grab this work from the execution queue and start that. And of course, this will run concurrently as well. So it's going to immediately fall and start processing. So this even allows me to increase the throughput of that. I can apply this exact same model to the system concurrent background queue. And here I have a new serial queue called the network result queue. And anytime I'm done retrieving an image or retrieving data, I don't want to do any handling or processing on the execution queue thread, and I'll throw that work over into the result queue. And that allows me to maximize the throughput of these threads and throw the handling of the result or the response to another serial queue. This is the model that I propose, and it's a good model, and you can actually add as many of these as you need for different modules. Of course, we don't have unlimited resources, so we have to be aware of the number of concurrency implementations that we have with different serial queues. But this is a model that works great for the demo application that I have, and this is exactly what I'm using. I have an execution queue and a result queue.